Quiz solutions. So there's a few key aspects to this graph, and I think it's these first three questions here, first three parts right here, that are sort of analyzing and telling us something about limits in general that's going on with this part of the graph. So as x approaches -3 from the left, so as I'm approaching from the left, what value am I approaching? And I'm approaching, remember, we're always looking at the y value, so I'm approaching 6. And then from the right, what value am I approaching as I'm coming over here? Well, I'm approaching 2, right? So 6 and 2. And then why do we say, so then notice it's got from the left, from the right, and then here it's got nothing, so it's just the limit as x approaches -3. Why do we say it does not exist? Because the left-hand limit and the right-hand limit aren't the same. So that's something we've seen more at this point in the unit, and hopefully we've got a good handle on that. But that those three questions together highlight an important property or important idea around limits. The next two, again, kind of go together. The limit as x approaches 1. So as x is approaching 1, from the left, I'm approaching 4, and from the right, I'm approaching 4. So because the left-hand limit and the right-hand limit are the same, they're both 4, the limit overall as x approaches 1 is 4, even though the function does not exist at that point. So that's part of the definitional limit. The function doesn't have to exist as long as it's approaching the same y value, same function value from both sides. And then, again, this one just highlights a slightly different idea that, again, I'm approaching 7, so from the left and from the right, as x is approaching 4, y is approaching 7, or the function is approaching 7. So the limit as x approaches 4 of f at x is 7, even though the function actually exists somewhere totally different. It's 9 there, so it just happens. That's what we call like a pop out. And so the function's 9 there, but that doesn't matter. That's not the limit. Only cares about what it's approaching. Okay, so you put all those together, you get a pretty good picture of what is going on with limits. For this question, it's an absolute value, so the technique we use is left-hand limit, right-hand limit. I know I played a little joke, but you know, it is a good idea to mentally or do it off to the side or something and actually sub in and make sure you get 0 over 0. It's certainly possible on a test that you'll get a question that evaluating the limit is as easy as substituting. In fact, that was one of the strategies that we used, was substitution. That was the first way we talked about solving limits, was by substituting. It's only when they're indeterminate, 0 over 0, where we have to use one of the other strategies. So for absolute value, we do left-hand limit, right-hand limit. And we do that because of how we think about the absolute value when the argument of the absolute value, that's the thing inside the absolute value signs, when it's less than 0, which will occur in this case when x is less than -2, I put a negative sign in front. And then I just evaluate the limit as normal, and I see what I get. So in this case, I got positive 1 over 6. And then in all other cases, if the argument is positive, so when x plus 2 is positive, and that's when x is greater than -2, then I just leave it alone. I just leave it as x plus 2, because that's what the absolute value function does. If it's negative, it makes it positive. If it's already positive, it leaves it alone. And when I evaluate that, I get negative 1 over 6. And so because they are not the same, the limit does not exist. And you probably saw a bunch of those with absolute values, but it doesn't always happen, so be careful. Sometimes you can get it that the limit does work. Okay. I think that's that one pretty well done. Overall, the quiz was really well done, in fact. These substitution ones can be a bit tricky. So first of all, what we want to do is we want to substitute something for this guy, because it's kind of messy to work with rational exponents in these. So I'm going to substitute u in as a to the 1/6. And then because I'm subbing a out, I need to find something that I can sub in for that a as well. And so if I rearrange this and I get a, then I can sub out both the a's. I can get the a to the 1/6 out and just the a on its own out. And when I do that, I have to make sure that I reevaluate what my limit statement will be. And I do that by taking the thing that a was approaching and summing it in and just figuring out, literally I sub in and figure out what u is, and then that's what u approaches. As a approaches 64, u approaches 2. So that's how we do that little trick. Remember, I said there's sort of 3 important points to this: 1, 2, 3, typically 3 mini steps to doing that part to get ready for the substitution. Then you do the substitution, and this one happened to look a lot like, I think, one of the ones we saw in the lesson, where you have to do a difference of squares and then a difference of cubes, or a difference of cubes and then a difference of squares. It doesn't matter the order. About half people did it one way, half people did it the other. It was kind of interesting. And make sure you don't lose any of the binomials or trinomials while you're working through there, because some people do that, and so they end up just with getting the wrong answer in the end. You know, you lose 1 mark, everything else looks good, but you sort of dropped one part of it along the way. Well, it probably wouldn't be that part, but maybe that part or something like that. Okay, so I did my difference of squares, and then I took this one to do a difference of cubes, because that's what's going to get me the factor that I want. That's going to divide with the top. That's the whole. That's the thing that's making the limit indeterminate. So, and again, it was 2 minus u. So I had to multiply that by -1 or factor out a -1 so that I got u minus 2 that I could factor on, that I could divide out of the top and the bottom. Don't forget that negative sign. You can't lose it. So I end up with -1 over this sub in, and I got -1 over 192. Very well done overall. Quiz was, on average, was fantastic. Looked really good. If you have any questions, you can send me an email. Otherwise, I will see you Thursday morning. I almost forgot one of the most important things that I wanted to point out in these solutions, because several people did it and they lost the mark, is this word right here, let. Oh my goodness. It's absolutely required whenever you're introducing a new variable. It's sort of formality. Maybe it seems sort of picky, I don't know, but it's 100% required. So you've got to say let u equal that. If you, like, u doesn't equal that, you're letting u equal that. It's a difference. There's a real difference between making a statement that it's somehow true, or when we use the word let, we're communicating that we are introducing a new variable and we're letting it be that. Otherwise, somebody, you know, if they were looking this over, might ask, why does u equal that? I don't understand. So we're letting it equal that. So it's actually an important part. So make sure you introduce that. I'll try to remember to mention that Thursday morning as well. But it's certainly an important step.